Lines are a common type of function that can be graphed very easily. First, let's look at a simple example of a line. The first thing we notice about this line is that it slopes down. This is because as we increase the x value, move to the right, the y value decreases. It moves down. Downward sloping lines have a negative slope. Here's another example. Because the y value increases as we move right along the x-axis, this line slopes up. Upward sloping lines have a positive slope. There are many lines that slope up and down. For example, both lines L1 and L2 slope up. How can we tell the difference between the two? The slope of a line is something that we can actually calculate. We can see that line L1 is steeper than line L2, and we can measure how much steeper it is by calculating its slope. The definition of the slope of a line is y1 minus y0 over x1 minus x0 for 2 points x0, y0 and x1, y1. So we really just need to find 2 points on our line, plug in the values, and evaluate the slope. Let's try it on this line. To make our calculation easy, let's pick our 2 points where the line intersects each axis. So we see those 2 points here. Because point x0, y0 is where the line intercepts the y-axis, it is called the y-intercept. Similarly, point x1, y1 is where the line intercepts the x-axis, so it is called the x-intercept. Now let's calculate the slope. We need the values for each point. First, let's find the values for the first point. The x0 value for the point x0, y0, we just look at the point and go down to the x-axis, and we see that it's 0. So x0 is 0. Similarly, for y0, we look at the point, go over to the y-axis, and we see that it's 8. For the second point, we look at the point, go down to the x-axis, we see that x1 is 4. And to find the y1 value, we just look at that point, go over to the y-axis, and we see that y1 is 0. Now we can calculate the slope. We just plug in the points to our equation of slope. We see that slope is 0 minus 8 over 4 minus 0, or negative 8 over 4, or negative 2. But what does the slope really tell us? To help us understand, let's rewrite the equation for the slope. First, the numerator is y1 minus y0. This is really just how much y changes between the 2 points. We usually use the Greek letter delta to denote a change in something. So, we can rewrite y1 minus y0 as delta y, or the change in y. Similarly, the denominator x1 minus x0 is really just a change in x, so we can rewrite it as delta x. Thus, slope can be rewritten as delta y over delta x, or the change in y over the change in x. Since we divide by the change in x, it really just means how much y changes for a 1 unit change in x. Our last line had a slope of minus 2. So this means that each time x increased by 1, y decreased by 2. And we can see that here on the graph. That's what the slope tells us. So now we know that the slope is really talking about a rate of change. Again, it tells us how fast y changes for a 1 unit change in x. But does the slope give us enough information to uniquely identify a line? Consider the following 2 lines, L1 and L2. Both of these lines have a slope of minus 2, but they are obviously not the same line. The difference is their intercept. So if we know the slope of a line and either intercept, the y-intercept or the x-intercept, we can uniquely identify that line. The easiest and most common form of the equation of a line is called the slope-intercept form. It is y equals mx plus b. It gets its name from the fact that when a line is in this form, m tells us the slope of the line and b tells us the y-intercept. Let's write the equation of our first line in slope-intercept form. Recall the line, shown here in this graph. We already calculated the slope to be negative 2. Looking at the line, we see that the y-intercept is when y equals 8. This means the equation of our line in slope-intercept form is, remember slope-intercept form is y equals mx plus b. M is a slope, in our case -2. B is the y-intercept, in our case 8. So we just plug those numbers in, and we found the equation of our line in slope-intercept form. Finally, if we wanted to, we could solve this equation for x using algebra and obtain x equals 4 minus 0.5y. It's important to understand that this equation describes exactly the same relationship between x and y as our equation did when it was in slope-intercept form. It just doesn't conveniently tell us what the slope and the y-intercept is. That's the end of the review on the equation of a line.